Hello and welcome to another video from Ultramax Coatings, where we'll be talking about the type of paint coating failures and defects, why they happen and possible causes for them. Paint coatings are a complex combination of raw materials that must be mixed, applied to a prepared substrate and dried or cured correctly to perform to their maximum capability. Paint will be applied in diverse environmental conditions and is then expected to protect the substrate from the damaging effects of rain, sunlight, wind, heat, cold, humidity and oxygen, to name a few. They must also repel atmospheric conditions, and the coating must maintain its structural integrity, and of course, let's not forget, we need it to look good too. So let's look at our first paint defect type, abrasions. Abrasion defects happen when a portion of the surface coating is damaged or, in severe cases, completely removed, exposing the original substrate. This often occurs through contact with another object, such as the use of metal chains for lifting, cargo scrapes, fenders, or even the grounding of a ship. You can prevent abrasion with the use of abrasion-resistant coatings formulated with resins and extender pigments included, which resist abrasive effects. In severe cases of abrasion, the effects may be limited by an abrasion-resistant coating. However, impact damage is very difficult to prevent with a coating alone. Our second example of failures and defects in paint coatings is adhesion failure. This could be because surface suffers from contamination or condensation, an incompatibility between coating systems, or exceeding the overcoating time. By ensuring that the surface is suitably prepared, clean, dry and free from contamination, and by using the correct coating specification with recommended overcoating times followed, you can prevent adhesion failure. Example 3 is alligatoring, or otherwise known as crocodiling. No wildlife here. This failure is caused by internal stresses in the coating, where the surface shrinks faster than the body of the paint film, causing an effect that looks like crocodile skin. It's often caused by excessive film thickness and limited paint flexibility. For example, if a hard top paint is coated over a more flexible, softer undercoat, or the application of a top coat before the undercoat has dried. Alligatoring can be prevented by using the correct coating specification shown in the technical data sheets. It can also be prevented by avoiding excessive film thickness and avoiding application at high ambient temperatures. Failure 4 is bleeding. Bleed through is generally a full or partial redissolving of the previous coat or an ingredient of the previous coat, and can occur when strong solvents are used in the top coats. Bleeding can be prevented by using the correct coating specification and materials, by using compatible materials from the same paint system and using appropriate sealer coat if possible. Next up, we have blistering. There can be many reasons for blistering, and it's a common coating fault. Many factors can be involved here, including osmotic gradients associated with soluble salts, soluble pigments, corrosion products, retained solvents and solvents from cargoes, to name a few. Non-osmotic blistering is associated with cathodic disbonding, thermal gradients related to cold wall effects and compressive stress. To prevent blistering, ensure that you have the correct surface preparation and application equipment. Apply a suitable coating system after testing for soluble salts with a Positester by Defelsco. Consider which of the mentioned blister mechanisms may appear in the environment you are painting in, and try to rectify it before painting. Failure number 6 is blooming or blush. This could be because the paint film was exposed to condensation or moisture during curing, especially at low temperature, which is a common phenomenon with amine cured epoxies. Incorrect solvent blend can also contribute to blooming. To prevent blooming, apply and cure coating systems under correct environmental conditions, ideally not in heavy moisture, and follow the manufacturer's recommendations. Moving on to bridging, which is another common example of a coating failure. Bridging is mainly a human error coating failure caused by poor application to the surface, a high viscosity paint system, and failure to brush paint into the corners or over welds. Bridging can be prevented by brush applying a stripe coat into corners and welds and fill all cracks, or weld them prior to application of the full coating system. It is extra work, but it may prevent costly paint repairs in the future. Failure number 8 is bubbles or bubbling. A probable cause of this is trapped air or solvent within the coating that is not released before the surface dries. Air could have become entrapped during the mixing phase, or a high ambient temperature during application can also cause significant bubbling. A special note, when painting in marine situations and applying anti-foul layers, if you overcoat the anti-foul layer without first removing the leached layer and zinc silicates, you may find your entire paint finish will bubble and need repairing and then refinishing. This can also be found with factory applied coatings where application is by dipping, electrode deposition or roller coating. In spray application, bubbling can be prevented by adjusting the viscosity with thinners and following datasheet requirements for maximum application temperature. Use correct mixing equipment such as a paint shaker to ensure air is not stirred in during mixing. Apply a mist coat and add defoaming agent to emulsion paint. At number 9 we have cathodic disbonding. A probable cause is high over voltage, principally from impressed current systems, but also to a lesser extent with sacrificial anodes when the number of anodes is excessive. Factors are incorrect installation, poor monitoring and incompatible coating systems. To prevent this issue, use a well-designed cathodic protection system, regularly monitored with well-placed reference electrodes. An application of an alkali-resistant coating system will solve any future occurrence. At number 10 we have chalking, which is another common failure occurrence. A probable cause of this is disintegration of the paint binder on exposure to weathering or ultraviolet light, which causes a powdery, chalk-like substance to appear on the surface. To prevent chalking, apply a suitable top coat with high resistance to chalking and with ultraviolet resistance. Next, we move on to checking. This is typically caused by a formulation or specification problem. As with cracking, stresses are developed that cause the surface of the paint film to become brittle and crack. Another cause could be limited paint flexibility. By using a correctly formulated coating system, checking can be prevented. Sissing is next on our list of coating failures. This can be caused with surface contamination by moisture or a foreign material such as oil, grease or silicone. Sissing is also common when incorrect solvent blends have been used in the original mix. To prevent this, ensure the surface is clean and free from grease, oil and other contaminants prior to application of a coating. At number 13 we have cobwebbing. A probable cause could be too high a viscosity with some types of polymer. Cobwebbing will occur with chlorinated rubber paints at almost any viscosity. By reducing the spraying viscosity, selecting a more suitable solvent blend and changing the spraying conditions, you can prevent cobwebbing from happening. Cracking is number 14. Generally a stress-related failure and can be attributed to surface movement, aging, absorption and desorption of moisture and general lack of flexibility of the coating. The thicker the paint film, the greater the possibility it will crack. To prevent this, use the correct coating systems, application techniques and dry film thickness levels. Alternatively, use a more flexible coating system to provide a buffer against cracking. Cratering is at number 15. Cratering is trapped air or solvent bubbles that have been burst on the coating surface, leaving small craters as the coating dries. The coating therefore has insufficient time to flow into a uniform film. To prevent cratering, improve your spray technique, apply a mist coat and avoid air entrapment during mixing. You can always add thinners as recommended by the paint supplier to reduce paint viscosity. Coming in at number 16 of our list of defects is crazing. Another common paint problem, crazing most often occurs when application temperature is too low or below 5 degrees. Check out our link above on temperature for a detailed guide. It can also be an issue if there is an incompatibility with previous coatings, aging, or if there is a high film thickness. To prevent crazing, apply a thinner coat of paint, add slower drying solvent, check that application and drying conditions are correct for the paint system used, and check compatibility between previous coatings and the new coating. Crowsfooting is example number 17. Usually caused when the surface dries too quickly and forms a skin, which then wrinkles as solvent slowly evaporates from the soft underlying paint. Very similar to crazing in appearance, crowsfooting can be prevented by applying a thinner coat of paint, adding slower drying thinners, and check that application and drying conditions are correct for the paint system used. Failure number 18 is delamination. Provided that compatible paint materials have been used, delamination defects are generally related to poor surface preparation and application. Contamination between coats, exceeding overcoat times, or application to a glossy surface are the most frequent culprits causing delamination. To prevent it, ensure that no contamination occurs between paint coats. Follow the recommended overcoating flash intervals, lightly abrade and clean glossy surfaces between coats. At 19, fading is another routine paint problem facing regular sprayers. This can be caused by incorrect pigmentation, use of non-light stable organic pigments, atmospheric contamination, or a porous substrate that leaches away the original colour. To prevent fading, use correct coating systems that resist ultraviolet light and fading. Use a coating with light stable pigments to retain bright colours. Number 20 is flaking, an issue most industrial painters will have faced at some point. Flaking is most often caused by using an incorrect paint system. For example, using interior paint on an exterior object will most likely see flaking soon after drying. Either no or an incorrect pre-treatment used for certain substrates can cause flaking. For example, on non-ferrous or galvanised metals. Poor application techniques may also be attributed to differential expansion and contraction of paints and substrate. Natural products, such as wood, are good examples of surfaces which expand and contract and can cause flaking. It can also be caused as a result of normal aging over time, for which there is no cure. To prevent flaking, use the correct coating system and pre-treatment. At 21 is grinning. Not normally a failure in most of life, but in coatings can be pretty disastrous. When you can see a previous paint layer, such as a primer, showing through the top coat to the surface, it's known as grinning. It's caused by having a low film thickness of top coat, poor opacity, covering power of top coat, or possibly even too strong a colour of primer and undercoats. To prevent grinning, apply adequate dry film thickness between individual coats and use opaque coatings with good opacity. 22 is heat damage and could be described as a byproduct of an accident rather than a defect really. High temperature applied to a substrate will cause damage to almost any paint coating, with the most likely causes being burning, welding or fire. Ensure that all welding and burning work is completed prior to painting in order to prevent heat damage. The next defect of paint coating is number 23, impact damage. This is damage caused by an object coming into contact with a paint surface, most likely to occur with relatively brittle coating such as glass fibre, reinforced plastics. It also can occur when steel or any other substrate is deformed by impact. Ensuring your paint coating remains protected is the only defence against impact damage. Number 24, intercoat contamination is a tricky issue to identify. Examples of this issue could be contamination from inadequate washing down of the substrate. Alternatively, salt deposits from natural weathering will appear on the surface and if not cleaned before painting can cause paint faults. Even foreign deposits like soot from nearby operations can add contamination to a new coating. To prevent this, carefully inspect and test the surface before paint application and wash down with fresh water if required. Defect 25 is mud cracking. Generally an over-application of heavily pigmented primers such as inorganic zinc silicates or water-based coatings, although the issue can occur with other thick material systems. A prevention of this is to rigidly stick to recommended coating thickness from technical data sheets and only use recommended application techniques. For example, if a product is spray only, don't use a roller to apply.
Next up is orange peel, number 26. A common problem for automotive sprayers requiring premium finishes, orange peel is often caused by the failure of the paint film to flow out and results in the distinctive orange peel surface. Poor application technique is the most frequent reason for flow issues, but incorrect solvent blend or too high thixotropy, where the material temporarily becomes a fluid then sets to a solid, can also cause orange peel. To prevent this, use correct application techniques with suitably formulated products, especially when using 2K paints. At 27, we have peeling, a very common paint issue. Peeling is a reduction in bond strength of the paint film due to contamination or incompatibility of coats. A prevention of this is to use the correct coating system and specifications shown on technical documents and only apply coatings to clean and uncontaminated surfaces. Pinholes is defect number 28. and a very unusual issue to view if you are a spraying beginner. Solvent vapour or air gets entrapped within a paint film, and as these vapours rise through the paint layer, they create a mini volcano effect through the paint coating. It's not only a visual problem. If painting where a waterproof membrane is required, pinholes will leach moisture down to the substrate, destroying its waterproofing. To prevent getting pinholes in your paint coating, use correct application techniques with suitably formulated products. Check your data sheets for the correct solvent blends and paint in non-humid environmental conditions. It's also worth checking you are spraying from the correct distance of spray gun to surface and apply a mist coat. Number 29 is a rippled coating. A fairly easy defect to understand. This can be caused by strong wind blowing across the surface of wet paint, causing it to ripple. Where this occurs on the underside, the ripples can hang down in the form of small stalactites. It's also an issue that can be caused by poor application techniques. Prevent rippling by applying paint under calm, dry weather conditions and use professional application equipment. 30 is the runs. This is when there is an over application of paint, excessive use of thinners, incorrect or lack of curing agent, or poor workmanship. More often than not, the runs are caused by applying too much paint to the substrate, otherwise known as human error. So prevent it by using the correct application techniques and always checking your dry film and wet film thicknesses. Rust rashing brings us to defect number 31 and is generally caused by low film thickness, often in combination with a high surface profile. A prevention of this is to ensure that an adequate thickness of primer coat is applied to cover the surface profile, and check that the surface profile is not too large. Failure number 32 brings us to another rust related issue, rust spotting. You can identify rust spotting by dried iron salt deposits on a metal surface caused by corrosion. Probable causes of this can be low film thicknesses, voids and holidays. Steel defects such as laminations and inclusions can also cause spotting, as can a high surface profile with a number of peaks in the paint film. Another common cause is metallic contamination of a coated surface by grinding dust, which then slowly corrodes. To prevent this, ensure that an adequate thickness of primer coat is applied to cover the surface profile. Use a thicker coating system or a lower blast profile and protect the coating from grinding, dust contamination. At number 33, we are still with the rust family of issues. Rust staining can be caused by water runoff from a rusty surface above a soundly coated surface. Rust staining contaminates water and discolours other items or locations, usually more of an eyesore than a defect. The coating itself may not be defective, only stained, but in the painting world, that is still a problem to solve for the customer. A prevention on this is to ensure adequate design to stop water runoff and suitable maintenance of surrounding substrates. At number 34, sags is a very ugly defect for painters to deal with. When there is an over application of paint, excessive use of thinners, incorrect or lack of curing agent, or poor workmanship, it's likely you will cause a sagging or sliding of a coating. In extreme circumstances, it could also be a result of a formulation problem. The only way to repair this kind of damage is to sand back and start from the beginning. So to ensure you prevent sags, use the correct application. Defect number 35 is settlement. Settlement is when the paint coloration is not uniform across the whole coating and is the inconsistent finish ruins the job. This is a very easily avoidable fault, as the most likely cause is a lack of correct mixing at the formulation stage. Always ensure adequate mixing with a paint mixer to get best results. There are also other possible causes such as old stock or heavily pigmented paint, as found with zinc-rich primers. To prevent this, use products within shelf life. Use adequate mixing procedures and keep paint mixed or recirculated during spray application. Problem number 36 is skinning. This can be caused by the absence of an anti-skinning agent in the paint, use of non-airtight containers or non-original storage conditions, and often occurs in partly used cans. To prevent this, use an airtight container and store according to the official data sheets. In example number 37, solvent lifting is yet another example of paint coating failures and defects. Solvent lifting looks like a cracked crater in a desert. with ridges and flat areas throughout. It can be present when incompatible paint systems are being used together, or a top coat with strong solvent blend reacts with a previous and weaker solvent blended coating. Overcoating before the previous coat has adequately hardened is also a common cause of solvent lifting. The best prevention of solvent lifting is to use the correct coating specification, overcoating times and materials. Conduct compatibility trials with undercoats and top coats. At number 38 we have solvent popping. An ugly defect like pimples on the skin is caused by solvent evaporating so quickly from the wet film coat that the result void cannot be filled in time and a crater is left behind. Generally, incorrect solvent blends, porous surfaces, incorrect environmental conditions or high surface temperature are to blame for solvent popping, showing up in a wet film. By using the correct coating specifications, materials, application techniques and only painting in stable environmental conditions, you can prevent solvent popping. Staining is our defect number 39. When a solid or liquid imparts a discoloration to the coating, you tend to be left with a stain. To prevent staining, avoid allowing the coating to come into contact with solids and liquids that are prone to cause staining, or alternatively use dark coloured coatings where any staining would not be so apparent. Next up at number 40 is stress cracking. As the name suggests, stress cracking can be attributed to surface movement, aging, absorption and desorption of moisture, thermal cycling and general lack of flexibility of the coating. The thicker the paint film, the greater the possibility that cracking may occur. It often occurs around welds and changes in section that are difficult to coat accurately. You can prevent stress cracking by using the correct coating systems and dry film thicknesses, or use a more flexible coating system to compensate. Defect number 41 is undercutting. It creates an effect that looks like one coating running into another with a thick edge. The most likely cause of this is the application of paint to a corroded substrate. You may see rust creep from areas of mechanical damage which results in a missing primer coat. Undercutting often shows in areas of poor design and access where inadequate preparation and coating thickness was applied. In these same areas, maintenance may be difficult, which can cause the undercutting to worsen. To prevent this, use adequate coating, specifications and maintenance procedures and apply a suitable formulated primer. We're finally at the end of our mega list of paint failures and defects. Before we go though, here's one last defect, number 42, wrinkling. As the name suggests, this is when the coating surface contracts and forms a wrinkle. It can arise from overcoating before the previous coat is adequately hardened or cured, and follow on effect of one coating layer drying while one is still wet, causes a reaction and wrinkle. Over application of a paint coating can be a cause, particularly with alkyd coatings, as these types of material are naturally thicker, making it easier to over apply. To prevent wrinkles on your project, use correct coating specifications from your technical data sheet. Ensure you mix correctly and apply in thin layers to avoid overcoating. Forced curing with IR heaters will eliminate the risk of applying a layer to a wet coating. So that's it. I hope you found this video helpful. For more help or information, visit our website below.